Hey everyone, and welcome back. All right, so today is probably going to be our last lesson in Unit 1, and this is about inequality. So what we're going to do, we're going to learn how to solve inequalities, and I'm going to give you a word problem example as well, which isn't exactly an objective. It's still solving inequalities, but we're going to look at numeric ones and then also converting from a word problem. Essential questions for today: how do you graph an inequality on a number line? This is usually something we're going to be asked to do as part of our solution. We're going to graph the solution set. So our solution is not usually just one number. It's going to be a range of numbers or a group of numbers. And then what happens when you solve an inequality, but you divide or multiply by a negative number during that process? So how does that impact the scenario? All right, so basics of inequalities. An inequality is a statement that compares two expressions that are not equal, or they don't have to be equal. One is usually bigger than the other sometimes, so depending on these symbols, so like less than, they're definitely not equal to each other. Less than or equal to, they could be equal, or they might not be. And then not equal to, they're definitely not equal. If you get a greater than or less than symbol, that means that the number that you finish with, so x is greater than or less than 5, for example. So x is greater than 5, or sorry, x is less than 5. That means that x, the value of x must be less than 5. It cannot be 5. So it can be 4.99999. It can be 3, it can be 2, it can be 0.5. It can be anything less than 5, but it cannot be 5. So what we do is we get an open circle on a number line. So if we have a number line, and we have 5 on the number line, you would put an open circle on it, and then x is less than 5, we would be shading every value under 5. The arrow system, it's great if the variable is on the left. So if we have x is x, or a, or whatever your variable is, this is what it will look like on the number line. So the arrow is pointing to the left or to the right. What you will find though is sometimes you'll get like x and then the number will be on the left. So this is 5 is greater than x, or thinking of it the other way, x is less than 5. So you can also still read it from the variable to the number. I recommend you test some numbers out, and we will talk about that in a second. All right, so let's get straight into solving. In terms of how inequalities behave, they act just like equations do. So we're going to solve almost the exact same way. There's one exception to the rule, and that is when we multiply or divide by a negative number, the inequality, so the greater than, less than, greater than or equal to, less than or equal to, will flip over and change direction if we multiply or divide by a negative number. I'm going to show you what that looks like, but let's go through one where it doesn't happen first. So 4x plus 7 is greater than x minus 5. Just like as if this was an equation, I can subtract x from both sides, keeps them relatively balanced. 4x minus x is 3x, plus 7 is greater than minus 5 because x minus x is 0. They're canceled. Then I want to get x on its own, so the 7's got to go. I subtract 7 from both sides. 7 minus 7 is 0. 3x is greater than minus 5 minus 7 is negative 12. So then I divide by 3 on both sides. 3 divided by 3 is 1. X is greater than minus 4. Watch out for that negative. So x is greater than minus 4 would be my solution here. Going over to the right-hand side, minus 5y is less than or equal to 20. When we divide by minus 5 on both sides, this is one that should set off an alarm bell in your head. You're like, oh, I divided by a negative number, so that brings this special rule into play. Minus 5 divided by minus 5 is 1. Y is greater than or equal to 20 divided by minus 5, which is minus 4. So the big thing to note is when you multiply or divide by a negative number, the inequality sign is going to flip over. So write that down in your notes, star it, circle it, highlight it. You need to remember that if you multiply or divide by a negative number, you are going to change the inequality sign. All right, let's take those solutions and just graph them on a number line. So the first one was x is greater than 4. And the second one was y is greater than or equal to, oh, this one's different. But if I were to divide by -5 on both sides, sign would flip and I would get a -5. So let's just graph that one. Okay, so 4x plus 7 is greater than x minus 5. We get x is greater than 4. So remembering the first slide, if it's greater than 4, it cannot be 4. So I go to 4 on my number line and I put an open circle. And what I'll usually say is if you see the symbol in the beginning, just put a little reminder to yourself, okay, this one's closed circle and the other one's open circle. X is greater than 4. Pick a number either side of 4 on the number line. So let's just say like 3. And I would say 3 is greater than 4. Is that a true statement? And you would say, no, it's not. So 3 is not part of the solution set. If I try a number on the other side, 5, is 5 greater than 4? You would say yes. So therefore, the solution set is going to be to the right of 4. So x can be any number in this shaded area, and it will fit the inequality. So if x was 7, 7 is greater than 4. That works. Over to the right-hand side, our new solution, y is greater than or equal to -5. On -5, we put a closed circle because y can be equal to -5. So it is allowed to be equal to it, and it also can be greater than it. Sub in a number, -7 is -7 greater than -5. This is a common error that people would say yes, because absolute value 7, so +7 is greater than +5. But in negative terms, if you have -7 of something, you have less than someone who has -5. So this is not a true statement. So -7 is not part of the solution set, which means we need to shade the other way. So you shade all the way along the line until you get to the end, and then you draw an arrow to indicate this is going to continue on forever in that direction. So any number, -1 is greater than -5, 4 is greater than -5, 6 is greater than -5, they are all part of that solution set. All right, so let's take a look at some examples that you are going to do. So you're going to solve the inequality and then graph the solution set as well. You've got 3 problems to practice. Watch out for multiplying or dividing by a negative number. Pause the video, try it out, and come back and see how you did. Okay, so first one, 3x minus 2 is greater than 1. We want to get x on its own. Addition subtraction goes first, so we're going to add 2 to both sides. 3x is greater than 3. Divide by 3 on both sides, x is greater than 1. So I go over to my number line, I put a 1. Now this should be an open circle because it's greater than, not greater than or equal to. It's an open circle. And then x is greater than 1. I'm going to pick a random number. So 2 greater than 1. Is that true? Yes, it is. So 2 is part of that solution set. So I'm going to shade to the right. And then draw my arrow in. Second one. Minus 2x plus 5 is less than or equal to 4x minus 7. We've got to get the x's together, the numbers together. 4x is bigger than minus 2x, so to avoid that situation of multiplying or dividing by a negative number, I'm going to keep the bigger number on its side and bring the minus 2 over. So I'm going to add 2x to both sides. So I get 5 is less than or equal to 6x minus 7. Add 7 to both sides. That's 12 is less than or equal to 6x. Divide by 6. 2 is less than or equal to x. Less than or equal to is a closed circle, so I'm going to go to 2 and put my closed circle. And then sub in a number, so let's say 3. So 2 less than or equal to 3. That is true. So we're going to shade over to the right. All right, so now the third one, minus 6a plus 5 is greater than or equal to 23. Subtract 5 from both sides. minus 6a is greater than or equal to 23 minus 5 is 18. Divide by minus 6. So now alarm bell goes off in my head. I just divided by a negative number, which means my inequality sign is going to have to switch over. So a is now less than or equal to, and you got 18 divided by negative 6. A positive divided by negative is a negative number, and 18 divided by 6 is 3. So a is less than or equal to negative 3. Sub in a random number here, so let's say like 2. So is 2 less than or equal to negative 3? That's not a true statement. So 2 is in fact greater than minus 3. So we would say at minus 3, I put a closed circle because it was equal to. And then 2 is not part of the solution set, so I need to shade to the left. All right, so how did you do? If you have questions about that, make sure you're bringing it to class. I do want to go through one word problem with you. We're not going to see too many, but there will be one on your unit test, so I do want to bring it up. Tom wants to purchase a tent that costs $385. So far, he has saved $78 and plans to save an additional $20 per week. If W represents the number of weeks, write the inequality that represents how many weeks it will take Tom to save at least $385. This is kind of more real life. Like typically, if you have a fixed amount of money and you're saving some, you're not going to save right up to the exact amount you need. You're probably going to go over. So it's more of an inequality than an equation. But we've got $78, which is what we're starting with. So that doesn't change. And then we're adding $20 every week. So this is our savings. And we need that amount, so compared to $385, we need this amount to be either equal to, but inequality-wise, it can be bigger than. So if we overshoot $385, we can now afford it. If we're still under it, you can't. So the way our world works, if you don't have enough money to buy it, you can't buy it. But if you have more than enough, you can spend that and get change or keep some of it. So this is the inequality we are looking for. So this will help us figure out how many weeks it will take Tom to save at least, and that's the key word, at least 385. So if you don't see inequality anywhere, if you see the words at least or at most or under or over, that's your sign that this is an inequality problem. All right, what is the minimum number of weeks that Tom will be able to purchase the, what is the minimum number of weeks it will take for Tom to save enough to purchase the tent? Let's kind of like reword that a bit. So essentially, go solve it. So we got 78 plus 20W is greater than or equal to 385. So we'd subtract 78 from both sides. So that'd be 20W is greater than or equal to 385 minus 78 would be 307. And then we're going to divide both sides by 20. So yeah, this is not going to work out as a pretty number. So W is greater than or equal to 20 goes into 105 times. So this is going to be 15 point something. Let me pull out a calculator quick. 0.35. All right, so it will take more than 15.35 weeks to be able to afford this. So one way to look at this is if you're saving every week, then you don't really get to do decimals. So it's like every week I get paid, so I'm going to add in this amount. So at 15 weeks, we don't have enough. So that would mean minimum number of weeks. What we would actually need is W needs to be greater than or equal to 16 weeks. So on week 16, we will have enough to be able to afford it, and anything over week 16 will have more than enough. So hopefully you see that at 15 weeks, we would be just short. We would have $300. So on week 16, we'd add our next 20 in. Now we have more than the 385, so we would be able to then go afford it. All right, your practice work for this is the Solving Inequalities worksheet, which you can find in Schoology. Also passed out in class. We are working on questions 1 through 10 first, and then we will finish the sheet in class as well. Essential questions for today. How do you graph an inequality on a number line? So you would figure out what's your solution answer. So is it x is greater than or less than or greater than or equal to, less than or equal to, whatever the number is. So you put an open circle if it's less than or greater than. You put a closed circle if it's greater than or equal to or less than or equal to on that number, and then shade in the appropriate side. I usually check a number just to see, like, do I have the right side or not? What happens when you solve an inequality and then divide by a negative number on both sides? The dividing by the negative number is going to cause the sign to flip over. So a greater than would become a less than, or greater than or equal to would become a less than or equal to, or vice versa. And then for tonight, you're doing the solving inequalities worksheet, which you can find in class or on Schoology. See you all soon.